Welcome back, learners. As you know, in our previous lecture, so we have discussed about how to develop the simple Excel sheet in order to have the design of the concentric isolated footing. Now, so we have completely developed the Excel sheet for the design of concentric isolated footing. Now I will just add column in the top stating that column number. Okay, column numbers, right? So from here onwards we will start giving the column numbers. Now before we move on to the column numbers, right, so you know that what we are supposed to do is we are supposed to select the loads for which the column has to be designed. Okay, so as I already told, we have made a Excel sheet, right? So this is the Excel sheet representing the dead loads, okay, for in each and every column, and this is the this is for the dead load. So this is for the live load, and this is for the combination of dead load and live load. So by looking into these three Excel sheets, it is very clear that the load on which the columns for your combined loading, that is 1.5 dead load and 1.5 live load, is much higher compared to your only dead load and live load. So therefore definitely we have to design the columns, right? So for the for the combination of the dead loads and live loads, we have to design the column for the combinations of dead loads and live loads. So therefore I have opened this sheet. So now we have two options. So first let us design the column without any, okay, first let us design the column without any considering the moments at the base. First let us design the column without any considering moment at the base, right? So let us take only Fy. You can see here, out of all the values, sorry, our Fz value is higher, that is the load in the vertical direction is higher. Therefore I am supposed to choose this load, okay, on the columns. I'm supposed to choose this load on the columns. So we will see about this mx, my and mz later. Okay, we will see this mx, my and mz later. So first let us design this for only axially loaded column without any movement at the base. Okay, now so therefore according to this I have to concentrate on these, that is the load on the column as well as the column numbers. Okay, now when I go to column 53, the load on that column is 521.093. I can make it as 522 kilonewton, right? So therefore let us go to the first column number. I am going to give as 53. This is my column number. You know the grade of concrete, right? So whatever this is there, right, keep it in mind students, I have to drag this like this so that the same formula will be applied. Okay, sorry, yes. So now what I have to do, I have to give the grade of concrete, no change, it will be 25. Okay, so it will be 25, your grade of concrete will be 25, right? Now the axial load on the column, it was just for the sample, okay, it was just for the sample, so no need to consider, my actual design starts here, right? So for the column number 53, the axial load that it has to be designed is 522. Okay, so let me give the value here. So my load value is 522. Okay, this is my load. So therefore you can see here that I can bring here like this. So therefore automatically what will happen, your self weight of the footing, automatically it will come 52.5. then so your total load I will just bring like this. So it will be 574.2, that is 522 plus 52.4, 574.2. Then what is the moment at the base? So the moment at the base is 0. Okay, the moment at the base is 0. Right, the moment at the base is 0. So therefore now I have to give the safe bearing capacity of the soil. Now this was the project, it was done in my native, where the safe bearing capacity of the soil what we calculated was very high. It means it was a very good soil of 450 kilonewton per meter square. Okay, it was of 450 kilonewton per meter square. So it means the soil was very good in nature. Okay, I just like to share one experience with you learners. Usually in order to do the plate load test to find out your safe bearing capacity of the soil, it may cost you around 25 to 50,000 based on the availability of the plate load apparatus near your area. So maximum it may cost you 50,000, but most of the contractors or most of the clients, they feel that spending that 25 to 50,000 on calculating the safe bearing capacity of the soil is of insignificance. It means it is of no use, they feel. Okay, but when we do that, so we feel that we try to have the lower safe bearing capacity of the soil. Okay, so because when you take higher safe bearing capacity of the soil, you will not be having confident, right? So therefore we always, to be on safer side, we always try to have the lower safe bearing capacity of the soil. So when you have to try to have the lower safe bearing capacity of the soil, so definitely when the structure is not symmetrical in nature, the axial loads on the column as well as moments at the base of the columns are heavy, okay, compared to your symmetrical structure. So therefore the footing dimensions requires more and more, right? So but the client will not able to understand that how much extra amount that he is going to spend unnecessarily on these footing designs. So unnecessarily we have to make the footing dimensions more, we have to make the thickness of the footings more, we have to make the excavations more. Okay, so we have to increase the grade of concrete more in order to satisfy the footing designs. So unnecessarily the client is spending the money, and if you calculate that, whatever he is going to spend, that will be much more higher compared to his amount spending on the plate load test. So if you do the plate load test, exactly you will come to know the safe bearing capacity, and with any confidence you can go to the designs. Therefore my sincere suggestion, students, as an engineer, you should be in a position to convince the contractor or the client in order to go for the plate load test. You should explain him that how much amount that he is going to save if you do the plate load test, what are the advantages of those. Okay, so when we did this project, so I made the contractor to do the plate load test. So a plate load test can be done even if you have a diploma college or ITI college in your area, right? So in our place, the safe bearing capacity where this project conducted was 450. Okay, so it was 450. So therefore I can calculate the approximate area here. So therefore you can see my approximate area is 1.276 meter. So therefore what is the shorter area of the footing? The shorter area of the footing is 0.92, whereas your longer dimension of the footing is 1.38, right? So therefore now I have to apply manually that 0.92, let us make it as 1 meter, and the longer dimension of the footing, so let us make it as 1.5 meter. Okay, so therefore I will get the final area. Okay, I will get the final area. So this is my final area of the footing. Okay, yes, so this is my final area. Yes, so this is my final area, 1.5. Initially it was the approximate area is 1.2, now it has been increased to 1.5. Then what about this? So what about this? So this is your finding the Z value, right? So when I find out the Z value for these two, I used to get this much, right? So then the next step is moment at the base, right? So it will be 0. So therefore what will be a total load by final area of the footing? So that will be this one, total load by final area of the footing. So therefore what will be your maximum pressure? So this much. What will be your minimum pressure is this much. Okay, so that will be your maximum pressure and minimum pressure. right? Yes. So once this is done, next step is writing the shorter dimension of the column, right? So shorter dimension of the column. Okay. Now in order to do the shorter dimension of the column, you should know what are the 3 column dimensions that we have taken. Okay, you should know what are the 3 column dimensions that we have taken, right? So now according to that I will just show you, okay, according to that I will just show you that let us take the column dimension as 230 mm. Okay, let us give the column dimension as 250 mm, that is 0.250. Then the longer dimension as 0.40. Okay, so 0.230, 0.40. These are my column dimensions. Okay, yes. So then you can directly get the critical section of the footing. So how you got the critical section? Yes, this will be my critical section of the footing. I can calculate bending moment at the critical section, right? This is my bending moment at the critical section. Then next I have is the factored bending moment. So the factored bending moment is this one. Then I have to calculate that factored bending moment, which is in kilonewton meter to Newton mm. Okay, then I can just draw this box and I can say that it is effective depth of the footing. So you just add this value 50 to this. So then what will be your final depth? 266. I think this also I can make it to 300. Okay, I can bring it to this as 300 mm. Then you have the calculation of mu by bd square, right? Yes, just calculate your mu by bd square value. Now by looking into the chart you can say what is my percentage of steel required. I just open this. So what was the value that I am having? It is 1.79, right? 1.79. So I can go to 1.79 means I can almost go to 2. So 2 with M25 grade of concrete, it is 0.82%. Okay, so therefore I can give the value as 0.82%, right? So then I will be taking the AST value, right? So it is 2460 and I am using, let us take that 16 mm dia bars only I am using. So I will get the individual area. So then I can get the spacing of the reinforcement. It is 81. Okay, spacing of the reinforcement, it is getting 81. Okay, you are getting the spacing of reinforcement as the 81 mm. Okay, it is less than 300 and it is less than it is not more than 300 and not more than 0.75 times d, right? So therefore this also let me make it to the spacing of 80 mm, right? So let me give the spacing dimension as 80 mm, right? Okay, so this is my 80 mm spacing. Yes. So then you are supposed to calculate two-way shear. So based on the dimension you can get this is my two-way shear. Then what is the shorter of the punching influence line for this? Yes, this will be calculated. So then punching shear value, this one, then punching shear force is this much. Then this is the another value we required. Then what is your punching shear stress? Your punching shear stress is 0.87. Okay, your punching shear stress is 0.87. Then you know for the grade of concrete it is 1.25, so safe, no issues. Then we will calculate this distance d, then shear force here, then shear stress here, then 100 AST by BD value, right? You are getting 0.82, right? So you have to go to table 19, right? How much you are getting? 0.82. So 0.82, right? I can take it as 1. Okay, sorry, I think I made a mistake. So here when I calculated my percentage of steel required, it is 1.79. I was supposed to see this one, right? So what is my mu by bd square value? My mu by bd square value is 1.79. I can take it as 1.8, right? I can take it as 1.8. Yeah, I can take it as 1.8 with Fe415. With Fe415, it is 0.549. Okay, it is 0.549. So therefore automatically now this becomes, you can make it to 120 mm spacing, right? Yeah, here it is 0.549, right? 0.549 100 AST by BD. Now I have to see table 19, 0.549. Yes, 0.549. 0.549, it comes here. I can go to 0.50 also with M25. It is 0.75. I can go higher value, right? 0.49. Okay, so 0.49. 0.49, right? Yes, so this will be your punching stress value. Now like this you are supposed to do for all these columns, but let me make you one thing clear, students, that before this what I am supposed to do here is I should write my column dimension next to this. Okay, because we are supposed to give the column dimension. So therefore let us open our ETABS-StatBro file and let us write the column numbers, okay, or the column dimension, because you know we have three column dimensions. So therefore let us give that, let us write the dimensions. Okay, yes. So for my this one, if I want to open my software, I have to change my date and time. Okay, just give me 2 minutes, students. Yeah, so let me open my ETABS file. Because if we know the column dimensions, because you know for certain portions we have given one column dimension, whereas certain columns we have given another column dimensions. Okay, so therefore when we have the numbers here, so for each and every number we should know what is this corresponding column dimension. We should know what is their corresponding column dimensions. Okay, yeah, so we will write down that column dimensions, corresponding column dimensions. Yes, it will take some time to open. Your window is getting ready. Yeah, so now you know that this is my 53, right? You know this is my 53, but you should know what is the column that we have placed. Okay, you should know what is the column that we have pasted, right? So therefore what I will do is I will just give the one more window. So I will add one more window here. Now you can able to view this, right? So now you can able to view this. So 53, okay, yes. So now what I will do is I will go to this plan. You can see here according to that we have only two columns here. So I will go to elevations. Okay, I will go to elevations. I will go to A, right? So this is not my elevation. I have to go. I have to see here that it should come 34 and 53. So I have to bring till there. Yes, you can see here, this is my column 34, this is my 53, right? So therefore when I click on this, so I will come to know what is my column 3, that is 9 inch into 1 feet 6 inch. Okay, so therefore what I will do is I will just one add column here. Okay, I will just one add column here, and correspondingly I will write the column dimension. It is 9 inch into 1 feet 6 inch. Okay, it is 9 inch into, okay, 9 inch into 1 feet 6 inch. Okay, so that is for column 53. This is my dimension. Similarly, I can go to column 34. So for that also it is, I think, 9 feet 1 feet 9 inch into 1 feet 6 inches, right? Yes, the same thing I can drag here, column 34. Okay, then next I can go to this column, that is column 20. Okay, I can go to column 20. You can see this is my column 20. So what is the dimension of column 20? The dimension of the column 20 is again same, 9 inch into 1 feet 6 inch. Okay, 9 inch into 1 feet 6 inch, right? So this is my column. Yes, that is for that is for column 20. I have to cut this. I have to go to column 20. Yes, so this is my dimension for column 20. So then next after that I have column 35 and 36, right? I have 35 and 36. So what is the dimension of 36? Same. So the dimension of 36 is same. Yes, this one same. And what about your 35? Your 35 is also same. Okay, your 35 is also same. Okay, yes, your 35 is also same. Then next what you can do, let me go to this 54, 28, 32, 55. I'll go to this. Now you can see first is 54, right? Yeah, 54. What is the dimension? It is 9 inch into 1 feet 6 inches. Okay, that is 54. So 54 same. Then next you have is 28, column 28. It is 9 inch into 1 feet, 9 inch into 1 feet, that is 28. It is 9 inch into 1 feet. Okay, 9 inch into 1 feet. So that is the column for 28. Then next you have is 32. So for 32 it is 9 inch into 1 feet. Okay, 32 9 inch into 1 feet, whereas 55 also 9 inch into 1 feet. So 32, 55 both are same, right? So 32. Next you have is 50, 55. Yes, it is 55, 55. This one 55. Yes, 55. Okay, yes. So then after that next you have is 56. Next you have is 56. So 56, what we have, 9 feet into 1 inch, 56. Same, I can drag here. Then next you have 48. This is 9 inch into 1 feet 6 inch, 48, column 48. I have this one, column 48. Okay, column 48. Then next you have 57. So what is the dimension of 57? 57 also same. 57, where is 57? Yes, here 57. Okay, yes. So then next, after that you have 58, right? Okay, all right, 58, right? So 58, again this one, it is 9 inch into 1 feet, that is 58. Okay, 58, this one. Okay, then you have 52, 59, right? What is 52? 52, 9 inch 1 feet 6 inch. 52, 52 is this one. Yes, I can draw. Then after 52 I have 59, that is again 9 feet 1 feet 6 inch. 59, right? Yes, 59 is here. Okay, 59. Yes, so after 59, so then we have to go to this one. What is this? It is 64, right? 64, 64, 64, it is 9 inch into 9 inch. Keep it in mind. 64, 64, it is 9 inch into 9 inch. Okay, that is 64. Then after 64, next you have is 60. So what is 60? That is 9 inch into 1 feet 6 inch. That is 60. 60 is this one, right? 60, this one, 60. Then next you have the next you have 112, right? I have 112 here. What is that? Is again 9 inch into 9 inch. 112. Okay, 112, this one 112. So then we have to go to 76. Okay, we have to go to 76, only one column. What is that dimension? 9 inch into 1 feet 6 inch. 9 inch into 1 feet 6 inch. Okay, 9 inch into 1 feet 6 inch. What is that column number? It is 76, this one. 76. Okay, then next you have 68 and 72. 68, 68, 9 inch into 9 inch. 72, okay, 68, 9 inch into 9 inch. 68, this one. Then next you have 72. 72 is how much? It is 9 inch into 1 feet 6 inch. 9 inch into 1 feet 6 inch, right? Yes, so that is this one. Yeah, this one, that is 72. Then last we have these two columns, that is 80 and 116, right? So what is the dimension of 80? 9 inch 1 feet 6 inch, this one, right? So then last we have this column, that is 9 inch into 9 inch. Okay, that is 9 inch into 9 inch, right? Yes, so these things, they are in so they are in, one second, Yeah, so this, they are in sorry, that is they are in inch and feet. Okay, so since we have done everything in the form of mm's, so let us convert and let us keep it like this. Okay, yes, so if you convert, right, if you convert, yeah, if you convert 9 inch to it is 228.6. okay, it is 9 inch 228.6, that is nothing but here 230 okay. So 230 into what is your 1 feet 6 inch, that we have to see when you convert. So 1 feet 6 inch, when I convert 1 feet 6 inch to it is 457.2. I can make it as 458. okay, I can make the column dimension as 458. okay, so that is your 9 feet into 1 feet 6 inch columns. So wherever it is there, I can place this here, 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 here. Then here too also the same dimension. Here also we have 4 same columns. Then here also we have same. Then when it is 9 inch into 9 inch, it is 230 into 230. okay, it is 230 into 230. okay, one second. Yeah, 230 into 230, right. So here also, so 9 inch into 9 inch, only 2 columns. Then finally you have 9 inch into 1 feet, right. Yes, that when I convert, it is 304. I can make it as 230 into 300. okay, so it is 230 into 300. okay, so therefore what I can do, I can here, 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 right. So done. So now according to that, if I open my design Excel sheet, okay, so according to that, here I have to give my shorter dimension of the column number 53. So column number 53, shorter dimension is 230 into 458. okay, so 230 into 458, you can see 230, that is 0.230 into 458.458, or you can make it as 460. okay, that is better. You can make it as 460.460. okay, yes. So according to that, everything will change. You can see that here 266 300, right. So then here it is 122 120, right. So here everything is same, right. So then here also it is same, right. okay, so that will give you, for your column 53, I have to give the dimension as shorter dimension 1 feet, longer dimension 1.5 feet, and your overall thickness 300 and spacing of reinforcement is 120 right. So similarly, let us take another column. okay, let us take another column. So this is done, right. So what I will do is I will just I'll just give this. So this is done. So then next you have is 34, right. So for the 34, your value is 1036. I can make it as 1100. okay, I can make it as 1100, that is 34. Therefore I'll put here 34 34. This will be anyhow same, no change. So axial load I can make it as 1100, right, 1100. So therefore what will happen to self weight? 110. Then what will be your total load? 1210. So moment at the base 0. So safe bearing is 450. Okay, safe bearing is 450. So therefore what will be your approximate area when you calculate? It is 2.68. So what is the shorter dimension? 1.34. What is the longer dimension? 2.01. So therefore I can give the shorter dimension as 1.5, the longer dimension as 2. Right. So therefore what will happen to my area? It becomes 3. Right, it becomes 3. Right. Okay, so then I have to calculate moment Z value. Z value is 1. Okay, so your moment at the base, if you calculate 0. So what is your total load by final area of the footing? When you calculate, you are getting this much. Right. Just a minute, students. Yeah, so when I do that, this is 1.523. Yes, it is total load by final area. If you check, yes, this one, okay, correct. Here also let me check. Okay, correct. Right, so therefore I can calculate my maximum pressure. This is my minimum pressure. Now, so this is also the same column. You can look into this same column. Okay, that is 34. Same 230 and 460. I can give 0.230, then 0.460. Sorry. So therefore I can calculate the critical section. You can see almost 1 meter. Then the bending moment at the critical section. Then you have factored bending moment. Then you have the value. Then you can calculate my effective depth from this. So add a cover of 50 mm. So therefore what will be your 412, right? So therefore I can make an effective depth of 420 mm. Okay, so let us give this value. Anyhow we have to change it later, so let us give 420. Okay, so that is my effective depth. Then calculation of mu by bd square. I am getting the value 1.71. okay, so go to this table. 1.71. okay, I can go to 1.75 with 415.532. okay, I can enter the value 0.532, right? So therefore I can get my area of steel this much, the same diameter I am using. So area of the individual same. You can get the spacing as 89. okay, you can get the spacing as 89. If you want to reduce the dimension, you can reduce to 12 also, it is your wish. So when you reduce it, you are getting still more higher lower spacing. Okay, you can go to 16 as of now. Okay, so you are getting 89. I can go to 80 mm center to center. That also we will change it, right, because of some practical issues I will tell you, right? Okay, then when it comes to checking, right, so what will happen to this? This is my A0 value, B0 value. Then what is my punching shear value? This one. What is my punching shear force value? This one. Then I need one value here. So therefore I will get punching shear stress as 0.88 and permissible, you know, it is 1.25. so therefore safe. When it comes to one way, this is my D distance, this is my shear force, then what will be my shear stress? So this is my shear stress. So when I calculate 100 AST by BD, it is 0.532. Now I have to go to this column, 0.532, right? I can go to M25.57. okay, I can go to 0.57, right? So here also, this is also no issues, right? Okay, so like this for all my columns I am supposed to do. Okay, so that we will take all the columns in the next video, and we will start doing our remaining column, and next procedure what we are supposed to do we will discuss in the next lecture. Thank you, learners.